So this video is factoring quadratics, and it's just a continuation of the last video. So you could label this factoring quadratics part 2, or you could just continue on your notes from the last video. Our goal here is still to factor quadratics. In this case, we're going to factor a quadratic when a equals 1. So how do we factor a quadratic? So a quadratic in standard form is ax squared plus bx plus c. So this is the standard form of a quadratic. What we're going to do is we're going to factor this when the leading coefficient, in other words, when this number in front of x squared equals 1. So when your a value is 1. In other words, we would be factoring x squared plus bx plus c, where our a value is 1. So the number in front of x squared is 1. The steps that we'll use to factor this is first we'll identify the b and the c values. Then we'll find two numbers that multiply to c and add up to b. Our answer when a is 1 will be in this form. So parentheses x, and then another parentheses with an x in it. This will be the form that we're going to use for the first few problems in the notes. So this is our template that we're using when we factor when a equals 1. So let's get into an example. So like I said, this is a continuation of the last note. So we're starting here with example 8. So in example 8, we have x squared plus 17x plus 30. So let's just write the standard form of the quadratic so that we have it. So it's ax squared plus bx plus c. And then what we're going to do is we're going to identify our b and our c, because our a, in other words, our number in front of x squared, is just that 1. So our b, in this case, the number in front of x is 17. And notice it's positive 17, so I'm going to write 17. And our c, so our constant, so the thing without the letter, is 30. So I am going to list the factors of 30. So the factors of 30, 1 and 30, 2 and 15, 3 and 10, and 5 and 6. So they're all the factors of 30. Now I want to pick the two factors of 30 that multiply to 30 and add up to 17. So if we look at our factor list here, 2 and 15, those add up to 17. So I'm going to write a set of parentheses with an x in it, just using the template. A set of parentheses with an x in it. And then I'm going to put 2, and that 2 is positive, so I'm going to put plus 2, and then 15 in the other one, and that 15 is positive. So my answer is x plus 2 times x plus 15. So this is the factored form of that quadratic. Now, the order doesn't matter, so I could have said x plus 15 times x plus 2. It would be the same thing. So either one of these is correct for your answer. And let's just check. We can always check by just redistributing. So let's just go ahead and FOIL this real quick so that we can verify. So I'm going to do x times x is x squared. X times 2 is 2x. 15 times x is 15x. And 15 times 2 is 30. Combine like terms. So this is x squared plus 17x plus 30. So is this what we started with at the beginning? X squared plus 17x plus 30? Yes. So I know that I factored this correctly. So you can always double check your work by just redistributing. Example 9. So again, let's start off by just writing the standard form just so that we have it. So ax squared plus bx plus c. So this is the standard form of a quadratic. So again, our a, the value in front of x squared is 1. The b value, so our b here, the number in front of x, in this case, is 7. So our b value is 7. Our c value, pay attention to your c, is negative 8. So now I'm going to have to multiply to negative 8. So I'm going to need one positive number and one negative number. So 8, I'm going to do 1 times 8 is positive 8. So if I want it to be negative, I'll just, let's say, put the negative with the 1. Then negative 1 times 8 is negative 8. we could say 2 and 4, and let's maybe just put the negative with the 2. So these are all the factors of 8. So I just want to choose the ones that add up to 7, positive 7. So 8 minus 1, well, hey, that's 7. So this, when I do positive 8, subtract 1, I get 7. So I'm going to use my template, parentheses x, parentheses x. And in the first set of parentheses, I'm going to put a negative 1 because that 1 was negative. And the 8 is positive, so I'm going to put plus 8. And again, order doesn't matter. As long as you keep the negative with the 1 and the positive sign with the 8, you could have this flip-flop. You could say x plus 8 times x minus 1. So these mean the same thing. So here is my answer for this one. X minus 1 times x plus 8. Number 10, x squared minus 6x minus 16. So again, write out your standard form. Ax squared plus bx plus c. Our a value, the number in front of x squared, is 1. The b value, so b is negative 6. And c is negative 16. So let's list the factors of negative 16. So just like before, since c is negative, I'm going to need one number positive and one number that's negative. Because a negative, remember, a negative times a positive is negative. So I'm going to need one negative number and one positive number. So let's say we use negative 1 and 16. Negative 1 times 16 is negative 16. Let's use negative 2 and 8. Negative 2 times 8 is negative 16. And then let's use negative 4 and 4. So negative 4 times 4 is negative 16. So we want them to add up to be negative 6. So let's just check. If I add 16 plus negative 1, well, that's just saying 16 minus 1. That's 15. So that's not what I'm looking for. I'm looking for negative 6. Let's do negative 2 plus 8. Negative 2 plus 8, well, that's positive 6. I don't want positive 6. I want negative 6. It has to match, even the sign has to match. And then if I do negative 4 plus 4, well, that's 0. So the negatives on this side don't work. So when the negatives with 1, 2, and 4, none of those gave me the correct answer. So let's take the negative and move it to the other side. So let's make these ones negative. So negative 16 plus 1, well, that's negative 15. That doesn't work. 2 minus 8, that's negative 6. So this adds up to my b value when 8 is negative and 2 is positive. So if I'm using my template, I'm going to write parentheses x, parentheses x. And then I'm going to make sure that I calculate this correctly. So that 2 is positive, so I'm going to do x plus 2 times x minus 8. And again, order doesn't matter. You could say x minus 8 times x plus 2. Just make sure the negative stays with the 8. So either one of these is correct. You could FOIL. If you want to check your answer, you could just FOIL and you would get this answer out. The last example of this type, so I have x squared minus 22x plus 121. So write out the standard form, ax squared plus bx plus c. The a value is 1. So the number in front of x squared is 1. So this is x squared minus 22x plus 121. So I want you to identify the b value and the c value, and I want you to find the factors of c that add up to b. So pause the video and try to factor this one on your own. When you unpause it, I'll have a solution there for you. So in number 11, hopefully you gave it a try. So number 11, when you listen to factors of 121, you notice that the only one of those that add up to 20 or to negative 22 is if we have a negative 11 times negative 11. Because when you multiply that, you get positive 121. When you add them, you get negative 22. So your answer is x minus 11 times x minus 11. But remember, we could write this what this means is I have two x minus 11s. So since you have two of them, you could write it as x minus 11 squared. So both of these answers are acceptable for this problem. Type 3, we have factoring binomials using difference of squares. So difference, this is a key word here, difference of squares, it needs to be negative, and squares means that this needs to be perfect squares. So if you think of your perfect squares, like 4 is a perfect square because 2 times 2 is 4, 16 is a perfect square because 4 times 4 is 16, and so on. So those are your perfect squares. So when we factor a difference of squares, and notice it says a difference of 2 perfect squares. So you're really looking at 2 terms. So you only have 2 terms when you're factoring in this method. So if I have a squared minus b squared, so if I have 2 perfect squares, then that's going to factor as a plus b times a minus b. But what you're going to need to figure out is what our a and our b are. So let's look at an example. So example 12. Here I have x squared minus 16. Well, notice I only have 2 terms, so I can try to use this difference of squares. So I would ask myself, what squared, when I raise it to the power of 2 gets me x squared? Well, that's just going to be x. When I raise x to the power of 2, I get x squared. I'm going to bring down the subtraction sign. And then I'm going to ask myself, just like I did for x squared, I'm going to ask myself for 16. What, when you square it, gets me 16? And hopefully you recognize 16 is a perfect square. That would be 4 squared gets me 16, because 4 times 4 is 16. So I'm going to put a 4 inside that parenthesis. So why did I do this? Why did I figure out what squared got me x squared and what squared got me 16? Because this allowed me to identify my a and my b. So my a value is x and my b value is 4. My a is x because x squared gets me x squared, and my b is 4 because 4 squared gets me 16. So now I'm going to write, my answer is going to be a plus b times a minus b. And so if I fill in my template, it's going to be x minus 4, x plus 4 times x minus 4. And order doesn't matter as long as you don't switch the order of your a and your b. So we could say that this is x minus 4 times x plus 4. These would be the same thing. So it doesn't matter the order that you do it as long as you don't switch your a and your b. Number 13. So I have x squared minus 100. I have 2 terms, so I'm going to see if I can use a difference of squares here. So x squared, what squared gets me x squared? Well, x squared gives me x squared. I'm going to bring down the subtraction sign because I know this is a difference. And then what squared gets me 100? So what number, when you multiply by itself, gets you 100 is 10. So why did I do this? Well, I did this because this lets me identify, here is my a and here is my b. So x squared gets me x squared and 10 squared gets me 100. So this is going to factor as a plus b times a minus b. So I'm going to fill in my a is x. I'm going to do x plus, my b is 10, times x minus 10. So this is my answer. So I have one of each sign. 14, x squared plus 49. Notice I have a sum. So this does not factor because I have a sum. You can only use difference of 2 squares when you have subtraction. So you should be able to do the quizzes practice, which is posted in Google Classroom. You need to score at least 5 out of 6 on that practice assignment. You may take it as many times as you need to.